Hey everybody, good to see you today. We're going to try doing a lesson complete video. So follow along with me. We're going to start by correcting some homework and then we're going to learn something new. We'll take some notes and we'll do some practice problems. All right, it's good to see you. All right, let's get started. First thing, we have to correct our old homework, page 13 and page 50. So here you can see our assignment, and let me move it just a little bit here. All right. For 17 to 24, we were simplifying using the order of operations. So for number 17, we get 2. Number 18, we get 11. Number 19, we get 4.5 or 4 1/2. You do want it to be simplified. Number 20, you get 18. Number 21, we get 53. Number 22, we get 92. And 23, we get 16. And 24, we get 6. A reminder, you can use calculators on any of these problems. They're totally fine now. Just watch out for those square roots. If we see any of those, we probably won't need a calculator. For numbers 59 to 64, there's a lot of combining like terms because we don't know the value of the variable, so we can't simplify any further than that. For number 59, we get 5y squared. And number 60, we get 8c minus 11. Now, the order doesn't matter for us right now, but the symbol or the sign, the operation that comes in front of the number does. So you can also write negative 11 plus 8c, and that also be correct. 61, we get negative 3x plus y plus 11, or you could just rearrange that in a different order. Like you could have 11 minus 3x plus y. That's good too. Number 62, we get n minus 4m plus 1, or again, you could have 2, so you could have n plus 1 minus 4m, just in different order. That's good. 63, 3h squared minus 11h minus 3, or maybe you wrote it as minus 11h plus 3h squared minus 3. Again, all the symbols are fine and the numbers are right. They're just in a different order, and that's okay. 64, we get ab, or you could have 1ab plus 2ab squared. All right, so if you need to pause the video, pause it now to finish your corrections, and then go off to Schoology and turn it in, and then come back and hit play, and I'll continue on with your lesson today. There we go. So today, our topic is going to be a great one. I love this one in algebra. It's called solving equations. We'll look at some different ways to solve equations and some expectations for when you're solving. And this is part 1. We'll only do part 1 today. We'll have to do part 2 another time. So for solving equations, there's a couple different things that you'll run into. The first thing that you're going to run into is when we ask, is it a solution? What I mean by that is the number we have in front of us a solution to the expression or the equation that we're looking at? We use it a lot when we're checking our work, and before we get to that, though, we just have to see how to even begin to use it. So let's do a couple examples. Here's example 1. Let's say we have, I need a variable. It can be anything. Let's just call it y. Let's say we have y plus 1 equals 8. And then let's say that I'm telling you the solution to this is negative 9. That's one way I can show it, is I write a little semicolon and then the negative 9. Or the other way is I could write, is it a solution when y equals negative 9? Because what this is asking is this part that's unknown, this y, is this equation going to work when we plug in a negative 9? This is called substitution. So what we're going to do is we're going to use substitution to check the answer. So we write negative 9 plus 1. Does it equal 8? Look, I can put a little question mark over the equal sign. And then see -9 plus a 1 brings us to -8. Does -8 equal 8? No. So no, or we could write not a solution. That's a better answer than just no. So not a solution. See how that worked? Let's do one more example. Number 2. Let's rearrange the order of the equation a little bit. Let's write 6 equals 2n minus 8. And let's find out if 7 is a solution to this equation. Well, same thing as before. We're going to use substitution, and we're going to plug in the 7 everywhere that we see the variable. In this case, there's only one variable. It's right there. And we're using n's. The variables can be any letter you want. So to show my work, I do a step right here where I substitute in the 7. So I can write it like that. And now I start to simplify. 6 equals 14 minus 8. And I can even write the little question mark above because I'm checking, are they equal? Let's see, 14 take away 8 would be 6. So 6 does equal 6. So yes, a solution. There we go. It's really handy to find out if the numbers we're using work in the equation that we're dealing with. Okay? All right, let's go on to the next part. For these ones, we're now going to solve equations. And here's an example 1. Let's take 1.6, so 1 6/10. I'm going to use m for my variable, equals 1.28. So what this is saying is what number times 1 6/10 equals 1 2800ths? Well, I could use mental math, but that's going to take forever and that's going to be a really big hassle. So we're not going to use the mental math. Instead, I'm going to rely on a handy solution method. And the solution method is called inverse operations. Inverse operations mean what they are, or what they mean is that we want to undo. You can write over here, undo. I want to undo everything going on in this equation. And if we do that, we're kind of working backwards, and we'll get to whatever number needed to be there in the first place. So inverse operations are the opposite of the operation that's happening right now. So like addition, subtraction, multiplication, division, that kind of stuff. Here, and to start, I always find my variable because I want to get the variable all on its own. I want to isolate it on one side of the equation. So over here, I see that there's the m isn't alone. It's getting multiplied by 1.6. So what undoes multiplication? Division. Division is the opposite of multiplication, or we'd call it the inverse. And I want to undo times 1.6. And what undoes multiplying by 1.6? Dividing. So I'm going to divide both sides by 1.6. Now over on the left side, I can just do mental math. What's 1.6 divided by 1.6? It's 1. So all we have over here is an m all on its own now. I bring down my equal sign, and I can show that with a line there, keeping it all lined up. Now for 1.28 divided by 1.6, I'm going to use my calculator. Let's see what we get. 1.28 divided by 1.6 is 0.8. We like to put a 0 in front of it to show there are no values in the ones place. So m is 8/10, 0.8. We figured out what number times 1.6 equals 1.28. Now, I always want you on this solving equations part 1 to check your work. So let me show you how to run a check. To run a check, I try substituting that number we got into our original equation, just like what we were doing up here. So I'm taking my original equation, and I'm going to substitute in the 0.8. So I show my work like this. I go 1.6 times 0.8, does it equal 1.28? And now I'll use my calculator. 1.6 times 0.8 is 1.28. So 1.28 does equal 1.28. And in this case, I can just put a little check mark saying, yep, it worked. See, if you always remember to run checks, you can get 100% on quizzes, tests, homework, everything, because a check shows you if you did your work right. If this didn't come out to the right answer, then that means I made a mistake over here. So I go back and I fix that mistake. Okay, let's call this example 1 in solving. So let's do a total of 4 examples in solving, okay? Here's example 2. H plus 2.8 equals negative 3.7. So again, I want to do inverse operations. I want to isolate my variable. I see my variables over here. So I want to undo all the operations. In this case, there's only one operation, addition. And what's the opposite? Subtraction. So to undo the adding 2.8, I want to subtract 2.8. And you're totally allowed to change equations in algebra as long as you do the same thing to both sides. So I can subtract 2.8 as long as I also subtract it over here. And that's keeping my equation balanced and making it more useful for me. So I bring down the h. I'm going to write it over here. And I'm going to bring down my equal sign. And now all I need to do is negative 3.7 minus 2.8. On my calculator here, the way I get to negatives is by this button down here at the very bottom. So what I do is I type negative, and see there it is, 3.7 minus 2.8 is negative 6.5. Negative 6.5, and I believe that's my answer, so I go ahead and box it. Are we done? No, you have to run a check. Do you have to run checks on everything? Yes, on the assignments today you do. So I'm going to plug in, which means substitute. I'm going to substitute in my answer into my original equation. So is negative 6.5 plus 2.8 equal to negative 3.7? I sure hope so. So let's see. I go back to my calculator. I type negative 6.5 plus 2.8 equals negative 3.7. Yes. So negative 3.7 does equal negative 3.7. This works. What that shows is everything on the left side simplifies to the same number we had on the right side. Okay. All right. Let's take a look at number 3. Let's throw some fractions in here. 2/7. Algebra students love fractions so much. Equals 1/3. I'm pulling your leg. That's not true. A lot of us don't like fractions. Plus x. All right. Now, if you want, you can go ahead and just follow everything we've been doing so far, inverse operations, checking work, all that stuff. But let me show you a method that is going to work every time that's going to completely get rid of fractions. You're never going to have to use a fraction again if you follow this method. What I do is I look at my problem and I see that I have fractions and I don't like that. I want to get rid of them. So before I start to use my inverse operations, I want to do something called clear fractions. To clear my fractions, I want to change my whole equation. What I want to do is I'm going to rewrite it here. I'm going to take my whole equation and I want to change it so I don't have any fractions. And the way to do that, and we'll talk about more why this works, right now let's tell you what to do. The way you do that is we're going to take this whole equation and we're going to multiply everything in there by the greatest, or not the greatest, the least common denominator. The least common factor, smallest common denominator. That's what we're looking for. So what's the smallest common denominator with 7s and 3s? 21. So what I'm going to do is I'm going to multiply everything in here by the smallest common denominator. Is it least common denominator? Smallest, yeah. So it's actually the least common denominator. That's the better way to say it. Okay, so what happens? Well, what happens when you multiply 2/7 by 21? Well, when you're multiplying fractions, all you need to do is multiply the numerators. So 21 times 2 is 42/7 equals 1 times 21, so 21, and the denominator doesn't change. But now it's important that I also multiply the x by 21 because I can change my equation as long as I do the same thing to both sides. Okay? All right. So let me go ahead and simplify this now. If I did it right, all my fractions will go away. They'll disappear. They'll be cleared. What's 42 divided by 7? 6. What's 21 divided by 3? 7. And I bring down my 21x. Look at that, fractions are gone. Now I use inverse operations. So I want to get the x all on its own. To do that, I need to go reverse PEMDAS. So I need to undo this addition. If we're adding 7, minus 7 will undo it. 6 take away 7 is -1 equals 7 minus 7 is 0, so I don't need to write that. Here's my equal sign. So I bring down the 21x. 21 times x. To undo that, I divide by 21. Divide by 21. Interesting. It looks like my fraction is going to show back up. That's okay. They show back up at the end sometimes. What I get is I get -1 over 21 equals x. That's a very weird answer. I'm going to have to run my check to see if it works. So here's my check over here in this little space I have left. Is 2/7 equal to, question mark, 1/3 plus -1 over 21? Well, let's see, I need some common denominators for me to be able to handle this. Or I could go back and clear a fraction. But let me just create common denominators. This, if I multiply the top and bottom by 3, I get 6 over 21. Is that equal to, I need to multiply this by 7, top and bottom, 7/3. Plus a -121 is the same as -1 over 21. Okay, oops, I forgot to change my denominator here. This should be a 21. Ooh, I can do this math. 7 over 21 minus 1 over 21, 6 over 21 equals 6 over 21. It works. That is such a weird answer we got for that problem, but it works. There's my check showing it's good. All right, let's do one more. That got complicated really fast. Maybe you like clearing fractions, maybe you don't. I hope that you'll come to love them the more you have to use them. One more problem. This will be number 4, example 4. -2 1/2 equals, let's use y over 10. All right. I want to solve for my variable. Now I notice a couple things going on here. I notice that there's a mixed number. Here's a fraction with an unknown numerator. So I'm thinking what I'm going to do is I want to change this, I think, to a decimal. So I can do that. Let me do that. I know that this is the same as -2.5 equals y over 10. That's going to be easier to handle than the fraction. Or I could use clear fractions too. Now all I have to do is I have to get this y by itself. What undoes division? Multiplication. So I need to do the same to both sides and multiply both sides by 10 because that's what was doing the dividing over here. When I do that, I'm left with y. And over here, -2.5 times 10, you know what happens when you multiply a decimal by 10? The decimal moves to the right. So this becomes -25. And I could even check that on my calculator. But see, sometimes calculators take longer than just doing the mental math. -2.5 times 10, -25, yep. So I believe that's the answer. But how do we know for sure? we do a check. Do you do checks on all the problems today? Yep. Instead of using the negative 2.5, I already know that I changed it to negative 2.5, so I have to think a minute to make any mistake there. Not that I can think of, so I'll just use the negative 2.5 equals, actually does it equal, negative 25 over 10. I think I can do that mental math, but I want to make sure I don't make a mistake, so I'm going to go ahead and use my calculator. Negative 25 divided by 10. Yep. So my check worked. That is the solution. Okay, so today we talked about solving equations. We did it by checking to see if something's a solution or not. And you have to watch because sometimes what you'll see is this little semicolon saying, hey, try using that number, see if it's a solution. We tried that, and then we went through and we solved some equations using inverse operations. We talked about using checks, and you were introduced to clearing fractions, where if you see a fraction in a problem, you can get rid of that. I think my document camera just froze. That's okay. We're finishing up anyways. So you can use clearing fractions, and the way you do that is you would want to always multiply by the least common denominator, and you multiply everything in the problem. And then if you do that, the fractions will go away. Sometimes they come back at the end, sometimes not, but it's just a nice way to go ahead and go through without having to deal with all of that. So let me see if I can get my document camera back on here. There we go. All right, so let me give you your assignment today, and it's also on Schoology, so maybe you already saw it. We are going to be working on a couple of different pages again. I would like you to do page 57, numbers 19 to 24, and page 85, numbers 23 to 26, but then we're going to skip some, and we're going to go up to 39 to 45. So use your notes to help you. Remember that you need to show checks for every problem. We're not always going to do that, but since it's the first time we're trying it out, we're going to do it on this assignment, okay? All right, good luck with that. If you need any help on anything, if you rewatch the video, you can send me a message. This is a little weird doing it all by video, but we'll see how it goes. All right, I'll see you guys next time. But how do I end my video? Who knows? Let's see, I'll stop that. There we go. All right, bye everybody.